following on from the previous video, we used this to model this. But suppose we don't use this. Suppose we don't use this. Suppose we were to use, let's say something like this. Hang on. Suppose we don't use this here. Suppose we were to use hang on. Suppose we were to use hang on, let me think. 1 minus x squared instead of this. Now we could use this 1 minus x squared, so it's like this. But 1 minus x squared here is not a good model because you see 1 minus x squared. Yes, you're going to get you're going to hit most of your hits will be centered around your target. So it's quite good. But the thing is, this thing here doesn't take into account that there's a possibility that you might mishit it and it lands somewhere out here. So it lands somewhere out here. This 1 minus x squared here, it's forcing you to land within. It's forcing you to land within this region here. It's forcing you to land within this region here. This model here is no good. This one here is better because it actually takes into account that you could hit it around here, or you could overshoot miles away. It does take it into account, because if you get a graph plotter and plot this, it will look like this. You see, over here there is a possibility that you could land miles away from your target. It does take it into account, but it's tiny around here. It's probably 0.000. The point is that this model here is good in that it does take into account that there's a chance that you might hit it miles away. It does take that into account, but the probability here is really tiny. The further out you go, the lower and lower it will get. So this model here is good in that it takes that into account. This 1 over x, this 1 minus x squared model here is just rubbish. It's forcing you to land within this region here. Okay, it doesn't take into account that it might land around here. But the important point here, the important point in the last video is that remember the height here represents the number of hits, the frequency, or this here you can think of it as being a histogram. The important point of the previous video is that you have to take the height and the distance away from your target into account. Well, the height here represents a number of hits, or the frequency at which you land at a certain point. The width here is how far away you are from your target. So, but the thing is, you've got to combine the frequency with the distance away from the target. Meaning, if you combine the two, you are looking at the volume. So for us to really model this scenario later on, we've got to think about a 3D model. It's you combining, so it's you really revolving this around 360 around the y-axis, giving you a three-dimensional object. Because we want to combine the height and the distance away from the center. So because we want to combine the height and the distance, we've got to look at the volume, a 3D volume. So bear that in mind.